Day 12. This is the review for Unit 2, Part 2. This is the Advanced Polynomial Unit. And we covered a lot of information about polynomials. So let's roll up our sleeves and dive in. Do not have a pencil or a pen in your hand. If you have a pencil or a pen in your hand, put it down. Watch the video. Learn what you need to learn. But then go back and do these problems on your own. Okay, problem number 1. List all possible rational zeros of the function. When I say possible, I am indirectly referring to what is known as the rational root theorem. Now, according to the rational root theorem, the possible zeros work like this. The possible numerators all come from the constant term, which I'll put a C for constant, and the possible denominators come from the leading coefficient. Okay, so in this particular case, the constant term is 6. So the possible numerators are the factors of 6, which are 1, 2, 3, and 6. Those are the possible numerators of the rational zeros of this function. The possible denominators come from the leading coefficient, which is 2. So therefore, the possible denominators are 1 and 2. Now, if we mix and match these numerators with these denominators, okay, first of all, if I put all of these numerators over a denominator of 1, we get 1, 2, 3, and 6. That's 1 over 1, 2 over 1, 3 over 1, and 6 over 1. It's all of these numerators over a denominator of 1. Obviously, we don't show the 1. Then if I put all of these same denominators over 2, I'm talking about 1 over 2, 2 over 2, 3 over 2, 6 over 2. Those will be the other possible rational zeros of the function. So here I go, 1 over 2. There it is. You're welcome. But 2 over 2 is 1, and we've already got that, so I'm not going to write it down. 3 over 2, write that down. But then 6 over 2. 6 over 2 is 3, and we've already got that. Alright, and then please understand that each of these could be positive or negative. So we have to go through and put a plus or minus in front of every one of these. So 1, 2, 3, 4, 5, 6, 12. There are 12 possible zeros, rational zeros for this function. This does not include imaginary numbers or square roots or things like that. Okay, I guess I should have put that on the line. There you go. Write f of x in factored form. Show all work for full credit. So, I often ask you for the factors and the zeros. That's all I'm asking you for. Factored form and the zeros. This is 4 terms, so the first thing I look for is grouping. But here I see I have a 2 and a negative 1, and then a 13 and a 6. There's no way I can sort of pull out a GCF and make those look the same. Grouping is not going to work. So what I need to do is start attempting, I need to find a root. Now, if I had a calculator, I would cheat and put this in my calculator and look for a 0. Did the directions say anything about that? No. I am going to assume that I'm not allowed to use a calculator for right now. So if I'm not allowed to use a calculator, then I'm going to just go in order, starting with 1, and I will try the synthetic substitution, synthetic division. So 2, -1, -13, -6. I'm trying it out. You know what I mean? So what happens is I get 2, and then so that's 2, and that's 1. 1 times 1 is 1, and that's -12, and that's -12. I did not get 0. You know what I mean? That's -18. That's garbage. So that didn't work. Now I will try -1 instead. Okay, now trying -1. I've got 2, so I always bring that down. So that's going to be -2, so that'll be -3, +3, so that'll be -10, so that'll be +10, so that'll be 4. That didn't work either. So now I'm going to try 2, because that's the next thing. Alright, so that's 4, so that's 3, so that's 6, so that's -7, so that's -14, so that's -20. That didn't work either. So now I'm going to try -2. Alright, so that's -4, so that's -5, so that's +10, so that's -3, so that's +6, so that's 0. Kabam! That worked. -2 works. So that means I will have a factor, because we're writing factored form, so I have a factor of x plus 2. And down here I'm going to be writing the zeros of the function. So I found a 0 of -2. Okay, and so there I have my factor. And anytime I get down to a trinomial like this, 3 terms, I'm going to put those variables back in. I can always factor this or use the quadratic formula. So if I put my variables back in right now, I get 2x squared minus 5x minus 3. So I can either factor this or use the quadratic formula. I feel like I need more space, so I have 2x squared minus 5x minus 3. Alright, by the way, so you just saw me do what I would do if I'm not allowed to use a calculator. I feel like I should show you what I should do if I am allowed to use a calculator. Alright, if I am allowed to use a calculator, the first thing I'm going to do is type the equation into the table feature of my calculator. And so I've got 2x to the third power, so that's going to be 2x to the third power. And then I've got minus x squared, so minus x squared minus 13x minus 6. So I've typed it in. I usually like to start at -10 because it rarely goes past that. Okay, and now I'll scroll down. I'm looking for 0 on the y side here. So I'm scrolling down, you see the, oh, there it is. 0, -2. So there's the first 0 I come to, and that's the -2 that I found by trial and error of my possible zeros. So if you are allowed to use a calculator, use the table feature and get to the 0 immediately. If you're not allowed to use a calculator, you will get to that 0 pretty quickly, but you may have to try a few choices that don't work until you find the 0. Alright, but from there, then it's all the same. Try to factor it. So let's see, 2x squared would be 2x times x. 3 would be 1 times 3. Whoa. or it might be 3 times 1. Inner, I have 1x. Outer, I have 6x. I'm trying to get negative 5, so let's see. If I have a positive 1 and a negative 6, that will make negative 5. So there's my positive 1, and this will give me negative 6. And a positive times a negative is a negative. So that is how you factor it. So I will add this to my list of factors. So 2x plus 1 and x minus 3. And I will add to my list of zeros negative 1/2 and positive 3. Now, it's probably pretty obvious where I got the positive 3 from. You might be thinking, oh, look, it's the opposite. But there may be a few of you that still have not absorbed how I get the negative 1/2 from 2x plus 1. Obviously, I can't just say, oh, it's the opposite. There's a little bit more to it. So just in case you're one of those like 3 people who still haven't figured this out. That sounded a little obnoxious. I apologize. Just in case you still need a little bit of extra guidance to make sure you understand. Does that sound nicer? What you do is you take this and you set it equal to 0. So 2x plus 1 equals 0. Minus 1 on both sides, so I have 2x equals negative 1. And then I would divide both sides by 2. Whoa, I missed. Whatever, close enough. And that is going to give me x equals negative 1/2. That's where I'm getting negative 1/2 from. I just kind of do it in my head. So these are the factors, and these are the zeros. Alright, that was problem number 1. Now, number 2. Given the graph of this function, find all the zeros and show all work for full credit. Now, how many zeros should there be? Hint, 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 hint. There should be 4, because the degree is 4. Now, right off of the graph, I see 2 of those zeros. I see 1 here and 1 here. Okay? So, you know what? I'm going to follow my usual pattern. So, I'm going to list the factors, and I'm going to list the zeros. Even though it only said list the zeros, but I'm going to do everything. So right off the graph, I see I have a 0 of negative 3, which of course would be a factor of x plus 3. And I see a 0 of positive 4, which would be a factor of x minus 4. Alright, those are kind of opposites. Now, so that's 2 of them. There should be 4. The other ones must be imaginary since they don't touch. So let's find them using synthetic substitution. Hold on, I'm getting a text message. We will do synthetic division with both of these zeros. So let's start with the negative 3. So let's see, I've got a 1, negative 3, negative 7, 21, negative 36. Alright, so that's a negative 3, negative 6, positive 18, 11, negative 33, negative 12, positive 36. Alright, I got my 0 as expected. Now I'm looking at these 4 and I'm looking for possible grouping. I have 1 and 6, and then I'm looking here, is there any GCF that will turn this into a 1 and a negative 6? No, 11 doesn't go into 12. So no GCF, no grouping. So, but that's okay. I have 2 zeros ready to go anyway. So I will go ahead and use the 4, and I will pick up from here right now with the 4, and I will simply draw another line. Well, that's too long of a line, whatever. Okay, I can stop it right here. So I'll just draw another line, and I'll keep going now using the 4. Okay, so if I bring this down, 1 times 4, so I've got 4, negative 2, bam, negative 8, 3, bam, 12, and 0. Painless. And now I've got my trinomial. And as soon as I get a trinomial, I win, because I know I can either factor or use the quadratic formula. So putting the variables back in, I've got x squared minus 2x plus 3. So I will try to factor this. I pretty much know this is not going to factor because of the imaginariness of the answers. But let's see what happens. So I've got x and x. I've got 3 and 1. And it looks good at first, right? Because I'm thinking inner 3x, outer 1x. The middle has to be negative 2. And I'm thinking I could get negative 2 if I go negative 3x and positive 1. So that would be my negative 3, that would be my positive 1. So why is this a fail? Because I won't get positive 3. Negative 3 times positive 1 would be negative 3. So as close as it is, I am getting the middle. This still is a fail because I don't get the positive 3. So that was my only shot. So this is unfactorable. So if I was asking you to put this in factored form, you would go ahead and stick this entire trinomial in the list of factors like this: x squared minus 2x plus 3. Now to find the zeros that go with it, quadratic formula. So just in case there's still a sad soul that still doesn't know the quadratic formula, I'm going to write it over here. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Alright, that's the quadratic formula, and it will give me the solutions to this. So opposite of b, there's b. So b is negative 2, so opposite of b is positive 2, plus or minus the square root. Alright, b squared minus 4ac, I like to calculate that separately. So b squared minus 4ac. B is negative 2, so b squared is 4 minus 4. A is 1, so I'm actually not going to put that down at all. And c is 3, so there it is. So there's b squared minus 4ac. So this is just 4 minus 12, so that's negative 8. So that's what goes under the radical, negative 8. All over 2a. Well, 2 times 1 is 2, so there you go. Square root of negative 8, you know, I got to reduce this and stuff. That negative under the radical, I know I'm going to have an I out here. If I'm allowed to use a calculator, then I will put the square root of 8 in my calculator, like this. But I know this is going to be 2 radical 2, watch. Bam! 2 radical 2. Okay, isn't that impressive? You might be thinking, yeah, but what if I'm not allowed to use a calculator? What if this is in the non-calculator part? And you're right to worry, because it might be. Square root of 8 simplifies like this. 8 is 4 times 2. So square root of 8 is the square root of 4 times square root of 2. But the square root of 4 is 2. And this radical 2 comes down. So that gives me 2 radical 2. Okay, so this becomes 2 plus or minus 2 radical 2 over 2. wait a minute, so that negative under the radical is going to become an I. So that I goes right here. So 2I radical 2. But we must reduce before we have the final answer. Okay, so we will reduce. We will use our heart to reduce. All of these are divisible by 2. So that is going to make 1 plus or minus I radical 2. Okay? And that's as far as that goes. So we will go ahead and list this separately. Plus or minus gives us 1 plus I radical 2 and 1 minus I radical 2. So the directions actually said find all of the zeros. So here they are, 1, 2, 3, 4 of them. But if I asked you to write this in factored form, or if I said factor, then there it is. You never know. Luck favors the prepared, darling. Alright, number 3. Find f of x. No, strike that. Given f of x, find all of the zeros, show all work. So, okay, same directions as last time. But just like last time, I am going to find the factors and the zeros. Factors and the zeros, just like we've been doing in class. Though technically, I only asked you for the zeros. Am I an overachiever? I'll let you be the judge. Okay, let's assume that I am not allowed to use a calculator. I'm not really worried though, because the possible zeros, okay? If I think about the possible zeros are all going to come from this constant term, because the leading coefficient is 1. So the possible zeros are just factors of 1. So in other words, plus or minus 1. I said possible zeros, but I meant the possible rational zeros. The ones that might show up on a calculator. Anyway, even if we were allowed to use a calculator, these are the only two that would show up if either of them work. So that's not many to try. So I'm betting one of these will work. So let's start with 1 and see how it goes. So we have coefficients 1, 3, -2, -3, and 1. Okay. Let's see this. That's 1. 1 times 1 is 1. That's 4. Times 1 is 4. That's 2. Times 1 is 2. That's -1. Times 1 is -1. Alright, so right away that works. I'm looking for the grouping though. And 1 and 4, there's no GCF here. So grouping is not going to work. So I'm really hoping that -1 is about to work. If not, I'm kind of in trouble. So I'm going to go ahead and, okay, we found 1. That works. So let's go ahead and list that among our zeros. So I found a 0 of +1, which means I have a factor of x minus 1. Please, 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 please let -1 work, because that's the only other one I've got. Okay, so here we go with the -1s. Pick up where we left off. Okay, fingers crossed. So we have 1. 1 times -1 is -1. So that's 3. 3 times -1 is -3. So that's -1, and -1 times -1 is +1, which gives me 0. Whew! So -1 also worked. Let's put that down, which gives me another factor of x plus 1. Great. Now, you can bet that this is not going to factor. As I put the variables back in, I see that we have, and I'm just going to bring it over here, I see that we have x squared plus 3x minus 1. Okay, this does not factor, so as far as factors go, this will be included as x squared plus 3x minus 1. So this would be the factored form of this polynomial right here. Now, to find the zeros, I'm going to go ahead and use the quadratic formula. So, opposite of b. b is 3, so that means I'm going to have -3 plus or minus square root all over 2a. a is 1, so 2a is just 2. Now, under here, and I'm going to have to do this off to the side like I always do, under here you do b squared minus 4ac. Well, b is 3, so b squared is 9 minus 4. A is 1, so I'm not going to put that, but c is -1. Now, a negative times a negative is a positive, so this will be 9 plus 4. Alright, and that is 13, positive 13. Okay, wow, 13 is a prime number, so that's not going anywhere. In fact, this is it. Like, this doesn't reduce. There's nothing, there's no number here, there's no heart that I can even draw. So this is the final answer from my quadratic formula. So that means that my remaining zeros are ugly, but I will separate them by plus and minus. So I will have -3 plus radical 13 over 2, and I will have -3 minus radical 13 over 2. Alright, so there are the factors, and there are the zeros. Some ugly zeros. Let us move on. Okay, number 4. Give a possible polynomial equation with the lowest degree for this graph. Okay. I'm going to look at the x-intercepts, which tell me the zeros. So I see I have an x-intercept at -2. Okay, as I begin to write the equation, so I have f of x. Because of the -2, I know I have a factor of x plus 2. Now this goes straight through, so that means this is a single factor, multiplicity 1. I see I have another 0 at +1. +1 tells me I have a factor of x minus 1. And again, it goes straight through, so single factor. And then I have a third 0 at 3, +3, which means I have a factor of x minus 3. It goes straight through, so it'll be just a plain x minus 3, not squared or anything. Now, this might be my answer. I just have to ask myself, do I need a negative on here? Looking at the end behavior, does this obviously this is some sort of odd degree. In fact, we've memorized that this is what a cubic looks like. It's just a matter of, is this the positive version or the negative version? What do you say? Hopefully you said this is the positive version. I always think of the letter n when I do this. this has the end behavior of a capital letter N. Alright, because it is a right side up N, that lets me know that this is positive end behavior. If this were an upside down N, like this, then it would be negative, and I would put a negative for the leading coefficient. But right side up N means that the leading coefficient is positive, so I would just leave it like this. So bam, there's a polynomial equation with the lowest degree for this graph. There you go. Number 5. Alright, so this is kind of the opposite. We're given an equation and we're supposed to make a possible graph. Well, here we go. X minus 4 lets me know that we have a 0 at x equals 4, positive 4. So here's my 0. This one should go straight through because it's a single factor. Here I have another 0 at x equals negative 1. So there'll be a 0 there. And this one should also go through. Okay, because again that's a single, and so the graph goes straight through at a single root. Let me change colors just so it's easy to keep track. Here I have a 0 at x equals negative 3. Alright, negative 3 is right here. Now, because this is a double root, the graph should bounce right here at the blue one. So keep that in mind. It's going to bounce at the blue and go through at the two pink ones. Now, we need to talk about end behavior. To talk about end behavior, we need to talk about degree. Let's see. I think I will graph this green. The degree. Let's see. There's one of these, and two of these. So that's a total of 4. So the degree is 4. That's even. Okay, so that means the end behavior will be like a parabola, either facing up or facing down. Which is it? Yeah, since there's this negative in front, that means it's a downward facing parabola like this one. So I'm going to throw this out. So I know the end behavior is going to be falling on the left, falling on the right, which is helpful because I know to start my graph down low. So remember, I'm going to bounce at the blue and then go through and through. It really rhymed. I must be cooler than I think. So I'm going to start from down low. So it's going to come up and it's got to bounce at the blue one. But then right away it's got a curve. You know, let me do that again. I might even zoom in. Alright, because these points are so close together, it's sort of hard to curve fast enough. So let me try again. So I'm going to start from down low, like this. Alright, I'm not going to make my hill too high though, because I have to curve right around and bounce. No, I lied. Okay, I got so distracted. I'm supposed to bounce at the blue one and go through at the pink ones. Remember, okay. One more time, bear with me. Okay. So, I'm going to start from down here and I'm going to come up and I'm going to bounce off of this. But then I've got to swerve around in time to go through right here. And then I've got to come back around and go through right here. Okay, so this graph should look something pretty much like this. Bounce, through. And we decided up front that the end behavior was going to be like a downward facing parabola. And you can see falls on the left, falls on the right. It matches. So there you go. That's what number, whatever this is, number 5 should look like. Okay. Number 6. Use the table to the right to answer the following questions. Okay, look, the main part of this table is the zeros. Okay, you see the 0 right here? So that means 3 is a 0. See that 0? That means 8 is a 0. Okay, so we were given 2 zeros, 3 and 8. Notice that this 96, that's nothing. 3 and 8. How many root zeros are there for this function? Explain. Well, the degree. So because the degree is 4, there will be 4 roots, which is the same as zeros. If you count repeated roots separately, okay, there should be 4 roots. Okay, use the table to find all the roots. Well, we found 2. And you know what? I'm going to do what I always do, and which is I'm going to write the factors and the zeros like I always do. So factors and the zeros. They only asked you for the zeros, but I'm just going to do both because on the real test I could ask you for either one or both. So far I have 3 and I have 8. So the 0 of 3 gives me a factor of x minus 3. The 0 of 8 gives me a factor of x minus 8. So there are 2 more zeros I need to find, so let's go. I'm going to use synthetic division. Starting with the 3. Let's see, what do we have here? 1, negative 11, 28, negative 44, and 96. Okay, so that's going to be 3, negative 8, negative 24, 4, 12, negative 32, and negative 96. You know what? I'm looking at this and I'm looking for grouping. And you know what? I see grouping here. I see I have 1 and negative 8, right? When I look for grouping, I look for a GCF, looking at each of the 2 groups separately. So when I look at this group on the right, I imagine, what if I divided both of these by 4? 4 divided by 4 is 1. Negative 32 divided by 4 is negative 8. 1 and negative 8. 1 and negative 8. That's how I know that grouping is going to work. So let's do grouping. Alright, it's good practice. So I mean, I could have used the 8, and that definitely would work. But this is a good time for me to show you, remind you how grouping works anyway. So grouping. So if I put the variables back in, that's going to be x to the 3rd power minus 8x squared plus 4x minus 32. Okay, so a little grouping never hurt anybody. Common factor here is x squared, so that will leave behind x minus 8. The common factor here is 4, so if I pull out the 4, and again that will leave behind x minus 8. See, these two are the same, so I can factor that out, x minus 8. That's going to leave behind x squared plus 4. Okay, so those are the remaining factors. This x minus 8 is the 8 that we knew we would find. Alright, the 8 that's on the chart. So I'm not going to write it again. So all I need to add to this is the x squared plus 4. Okay, so if I want to get the remaining zeros, I just have to do something with this x squared plus 4. It doesn't factor, I hope you know. So what I need to do is set this equal to 0 and solve. Okay, so if I do x squared plus 4 equals 0, you know how we do. Subtract the 4, x squared equals negative 4, take that square root. Don't forget your plus or minus. So that'll give me x equals plus or minus. Now the square root of 4 is 2. Because I had a negative under the radical, that's going to be 2i. Okay, so the remaining zeros are plus or minus 2i. In other words, 2i and negative 2i. Okay, so we were supposed to find all the roots, and here they are, 3, 8, 2i, and negative 2i. But if I asked you for the factored form, here it is. Alright, number 7. Write a polynomial function of least degree that has rational coefficients, a leading coefficient of 1, and the given zeros. Be sure to multiply it out. Alright, the main thing is these zeros here. Before we even get started, please understand that there's another zero, there's a fourth zero that's implied from what we have here. Does anybody know the extra zero that must be automatically included? The extra zero is negative 3i. Alright, imaginary roots always occur in positive negative pairs called conjugates. So if 3i is a root, negative 3i is also a root. So it looked like they gave us 3 zeros, but they actually gave us 4. And what we need to do to make a polynomial function out of this is turn these into factors. So negative 3 will give us a factor of x plus 3. 0 would give us a factor of x plus 0. But you really don't need the plus 0 part, so it's just x. And let's see, 3i would give us a factor of x minus 3i. Negative 3i would give us a factor of x plus 3i. See how they're opposites? Okay. So all we need to do is multiply all this stuff together. So if I were you, I would start by multiplying these together. So if I do that, it'll look like this. I will multiply x times everything. Distributive property. So x times x is x squared. X times 3i is 3ix. Okay, now I will multiply the negative 3i times everything. Negative 3i times x is negative 3ix. Negative 3i times positive 3i is negative 9i squared. Didn't he say something about I squared? Oh yeah. Mr. Burton taught us that I squared is equal to -1, so we shall not forget it. In the meantime, positive 3ix and negative 3ix cancel each other out. They're total opposites. Okay, so what I'm going to have is x squared, these are gone. Now, I squared is -1. So this is negative times a negative, so this will be positive 9. Okay, so that's what I get so far. Alright, and then if I bring down the rest, you know, I've got this x, and I've got this x plus 3, but I'm going to put the x in front, because I'm just more comfortable with that. So I have x times x plus 3, like this. In fact, you know what, let me go back. So, you saw me multiply these two together, and I got this. What I would like to do next is actually, I would like to multiply these two together now. But that's really simple, because I would just do the distributive property. So if I take this and I do the distributive property, I get x squared plus 3x. Okay, so there we go. So I've got x squared plus 3x times x squared plus 9. So one more time, I need to multiply these together with the distributive property. So I'm going to do x squared times everything. Alright, I think I'll put it over here. So x squared times x squared is x to the 4th power. X squared times 9 is 9x squared. Now I will multiply 3x times everything. 3x times x squared is 3x to the 3rd power. 3x times 9 is 27x. Now these are out of order, so I just need to rewrite these in order, and then I will actually be done. So I've got f of x equals, so in order, descending exponential order, I will have x to the 4th power, and then plus 3x to the 3rd power, then plus 9x squared, okay, and then plus 27x. Alright, I feel like I messed something up. Alright, no, maybe that's it. That's what it is. No, I think that's just what it is. Okay, so there you go. This is the polynomial. This is the final answer. Alright, number 8. You know what, I think I'm going to change this problem to make sure you guys know what to do when there are 3 terms. Alright, here we go. This would be a good one to do. This divided by this. So if I set this up properly, I will have x squared minus 4x plus 16, and then under the division symbol I will put this. But notice the missing terms. There's no squared term and there's no x term. So I will fill those in with 0 terms. So I will have, there's my x to the 3rd power, but here come 2 0 terms, so watch out for this. You know what, I think I'll use green. So I will have plus 0x squared and plus 0x. And then plus 64. So don't forget your 0 terms as placeholders. Now, looking at the x squared and the x to the 3rd power, you ask yourself, x squared times what is x to the 3rd power? Well, that would just be x. Now, once you have that x, you do the distributive property with it. X times x squared, well, that's x to the third power. X times negative 4x, that's negative 4x squared. X times 16, that's 16x. So I have all of this. Now I subtract by changing the signs. So this will become minus, plus, and minus. Okay, of course these will cancel out. And here I will have 4x squared. Then here I will have minus 16x. And then plus 64. I just bring that down. Okay, and then I start over one more time. And I ask myself, x squared times what is 4x squared? Well, that would be positive 4. So x squared times 4 is 4x squared. So anyway, I'm going to do the distributive property now. So 4 times x squared is 4x squared. 4 times negative 4x is negative 16x. And 4 times 16, I do believe, is 64. Look at that. So of course we subtract by changing the sign. So I'll have minus, plus, and minus. But look, all three of these are opposites. Cancel, cancel, and cancel. So I will have 0 remainder. Okay, in other words, this trinomial divides evenly into this binomial. Okay, so but this the answer, the quotient, is simply the x plus 4. Okay, please understand that if this had been some remainder, I'm just going to call it r for a moment, then I would have done plus r over, and I would have written all of this, x squared minus 4x plus 16. That's what you do when there's a remainder. So if this had been a 5, I would have put 5 over this and added it on. Alright, but there was no remainder, so that's it. Okay. Determine algebraically whether the given functions are even, odd, or neither. Now, it's been a long time since we've talked about this, so pay attention. First of all, we should know at a glance if they are even, odd, or neither. So let's see, I have 7, 3, and 1. These are all odd, so I actually know right away that this is going to be odd. Looking at this one, let's see, I have 3, 1. Now be careful. When there's just a constant here, this is like having x to the 0 power. And 0 is even. So I have some odds, and then I have an even. So that means this is actually neither. I know that's going to be neither. Okay, looking at the next one, I have 4 and 2. And again, this constant is like having 7x to the 0 power. And 0 is even. So I have 3 evens. They're all even. So I know that this will be an even function. So notice I'm not just talking about the degree. I'm talking about the function as a whole. So if it's going to be even, all of the exponents have to be even. If it's going to be odd, all of the exponents have to be odd. If there's a mixture, like I have here, then it's neither even nor odd. Okay, but we're supposed to do more than that. I guess I could have put this on the line here. Determine algebraically. So we know this is going to be odd. We know this is going to be neither. And we know this is going to be even. Alright, now how do we determine it algebraically? This is what I told you. For every problem, I want you to show the opposite function. So the opposite function will look like this. First of all, the symbol for the opposite of a function is negative f of x. And you get it by distributing a negative across everything. So this will make negative 6x to the 7th power, positive 4x to the 3rd power, minus x. So this is the opposite function. Okay? Then what you do is you substitute negative x for everything. Okay? So in other words, we're going to do f of negative x. So this is going to become 6 times, and I'll put a negative x in there. And then minus 4, alright, to the 3rd power, and I'll put a negative x in there. And it'll be plus, yeah, I see this x, so I'll put a parentheses, but I'll put a negative x in there. Okay, so I substitute negative x into everything, and I see what I get. So let's see what I get. If you do a negative to an odd power, the negative stays. So this negative stays. It'll a positive times a negative is a negative. So this will become negative 6x to the 7th power. This negative stays because it's odd. A negative times a negative is a positive, so I will have a positive 4x to the 3rd power. And this negative stays, but instead of putting plus minus, we will just put minus x. Okay? So this is what we get when we substitute negative x. Alright? This is the original function. And this is the opposite function. Alright, and what we learned when we first went over this was if you substitute negative x, if you get the opposite function, then it's odd. If you get the original function, then it's even. If you get neither, then it's neither. So if you look and you see, oh look right here, these are the same. Okay? It matches the opposite function. So we will just say, since it matches the opposite function, it is odd. Okay, so that's how you prove it algebraically. Alright, and you do the same thing for all of these. So I'm going to do it faster now that I've done it once. So I once again will do the opposite function up here. So this will just really quickly be negative 9 x to the 3rd minus 7x minus 5. Okay, that's the opposite function. Now, if I plug in negative x, in other words, if I do f of negative x, I will get this. Why did I put a negative 3? I'm really tired. I meant negative x, you guys. And then plus 5. Well, odd power, negative stays. So positive times negative is a negative. Negative stays. Positive times negative is a negative. Then I just have plus 5, which just stays plus 5. Okay, so this is what we end up with when we plug in negative x. This is the original function. And of course, this is the opposite function. Alright, it doesn't quite match the opposite function because this is negative 5 and that's positive 5. But it doesn't match the original function either because of the positive 9, negative 9, positive 7, negative 7. So it doesn't match either of the either the original function or the opposite. Since it's neither of those, then it's neither. And we just need to say that. Okay, so we will say, since it matches neither, whoops, alright, since it matches neither, it is neither. Okay, last one. Once again, we do our three functions. So we start with opposite, the opposite function. We put negative f of x. And we just distribute a negative sign. So this would be negative 3x to the fourth power, positive x squared, minus 7. So this is the opposite function. Okay. This is the original function. And now it's time to substitute negative x. So I'm doing f of negative x. So this would be 3 negative x minus negative x squared plus 7. Okay, when I have an even power, the negative becomes positive. So basically the negative goes away. So if this negative goes away, then I just have 3x to the fourth power minus another even power. So this negative goes away. So that'll be x squared. And then the plus 7 just comes down. So this is what I get when I plug in the opposite of x. Looking up here, this matches the original equation. If it matches the original equation, that means that it's even. That proves that it is an even function. Okay, so we can say, since it matches the original function, it is even. Alright, so that's how it works. You always do the opposite function and you find what you get when you substitute negative x in. If it matches the original function, it's even. If it matches the opposite function, it's odd. If it matches neither, then it's neither. Okay, now we're supposed to determine visually whether the given functions are even, odd, or neither. Well, we learned that if the function is even, then it's going to have y-axis symmetry. Okay, it'll have y-axis symmetry if it's even. All right, in other words, it should be symmetric around the y-axis, like this maybe. If it's odd, it should have origin symmetry. Okay, and that means if I rotate the graph around the origin, it should look the same. So if I were to spin this upside down around the origin, it should look the same. So this would be origin symmetry. So this would be even, this would be odd. Obviously, if it has neither origin symmetry nor y-axis symmetry, then it's neither. So look at number 14. Alright, is this even, odd, or neither? Say it out loud. Okay, this is neither. Okay, it was trying to be even symmetry because it has a vertical symmetry, but the axis of symmetry that it has is not the y-axis. It's not y-axis symmetry. Okay, it would have to be symmetric on the y-axis to be even. So that's why it's neither. Alright, number 15. Is this even, odd, or neither? Say it out loud. Okay, number 15 is neither as well. Okay, this is trying to be odd. If I picked the right point, this would have rotational symmetry. I could turn it upside down, it would look the same. But the center of this graph is maybe somewhere around here. Okay? Alright, it goes up and down, it goes down and up. This would be the center of the spin. And the center needs to be the origin. It has to be origin symmetry. It can't just spin around any old point. So that's why that is neither. Alright, what about number 16? Even, odd, or neither? Say it out loud. Alright, this is odd. Alright, this has odd symmetry. Let me see if these are separate. Alright, odd symmetry. I should be able to spin this around the origin and it should look the same. Now, so if I take this graph and I turn it upside down, alright, see how it doesn't look any different? You know what I mean? I could copy it just to make a point. Alright, probably covered up a different graph. But that doesn't matter. Let me line it up for a second. Okay, so these are the same, but if I take this and I turn it upside down, alright, the upside down graph, the right side up graph, I'm spinning it around the origin, it looks the same either way. So that's how I know that I have origin symmetry. And origin symmetry is odd. What about number 17? Last chance. Alright, is this even, odd, or neither? Say it out loud. Alright, this is even symmetry. Alright, we said it would be even if it had y-axis symmetry. And you can see the y-axis splits this image right down the middle like a mirror. Alright, this is a reflection of this. This half is a reflection of this. So it has y-axis symmetry. That makes it even. Okay, so that is a nice little snapshot of what we have learned in this unit. Okay, if you know every single thing that I just covered in this review, you will at least pass. Maybe more. This is a pretty good start. Obviously, if you want to just be the master of your domain, then you will go back and look at every homework that we've ever done and the classwork as well, and make sure you know every problem. But this is if you don't have that much time, at least make sure you know every single problem on this paper, and you could do it without looking at your notes or watching any video. Alright, I will see you on the next video. I hope it was helpful to you.